Good morning. We are going to continue looking at Unit 12. Today we're going to look at something called standard deviation, but first let's do a little bit of review. So go ahead and pause the video so that you can answer these two questions and then come back and we'll check our answers and see how they match. Okay, so find the mean, median, and mode. Remember, with the mean, we are adding up all of the values and then dividing by the number of terms. So in this case, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. So I'm going to add up all of these. And when I do that, I'm going to get 142 divided by 10. So the mean is going to be 14.2. The median is the middle number. So I need to put my values in order from least to greatest. So I've got 0. Next up is 10, then 11, then 14, 15, 16, 17. Then we've got two 19s. Oops. And then 20. So my median is just going to be the number that's in the middle. If I count in toward the middle, that would be these two numbers. And so I have to average those. Add them together, divide by 2, and I get 15.5. Mode 19, because it's the only one that repeats. For the box and whisker plot then, I'm going to make a number line. I'm going to make this over to this side. All right, and my least value is 0. My max value is 20. So let's put 10 there, and then 5 and 15. Remember, it doesn't matter what you count by as long as you're consistent in your counting. So I have a point at 0 for my minimum and a point at 20 for my maximum. I have my median of 15.5, which is going to be just a bit past 15. There we go. And then I need to find the upper and lower quartiles. So since this had an even number, I'm going to draw that line in the middle, find the median of these data points here, and that would be 11. And then the median up here would be 19. Draw my box going through these values and the line through the middle. And then I just need to draw my whiskers. All right, so that would be our box and whisker plot for this data set. So that's a little bit of a review from yesterday. Now let's move on to today. So we looked at central tendency, and remember that was saying, like, where's that middle value for our data with a single number? So we did mean, median, and mode, but we're going to look now at measures of variation. And so this talks about how is the data spread out. So if we look back on this slide, we say, oh, we can see that it was spread out between 0 and 20, but really it's still talking a little bit about like that central tendency. It's saying where's the middle value. So interquartile range, we talked about this yesterday, or I mentioned it yesterday, but you didn't have to do any calculations. It's simply finding the upper quartile minus the lower quartile. So what's that spread of data? So the range and the interquartile range, what I need to do for this is put them in, oh, they're already in numerical order. You're welcome. And then I need to find the range. So to find the range, I'm just going to take the maximum minus the minimum. So 86 minus 56, which is 30. So that means that these values are spread out over 30 units. I don't know what we're measuring right now, but 30. So for my interquartile range, or my IQR, I need to find my upper quartile and my lower quartile. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 points. So that means that this is my midpoint. So I find the lower quartile by averaging these two together. And when I do that, I would get 60.5. And then I need to average these two together, which would be 83. So I'm going to say that my IQR is 83 minus 60.5. And that's going to give me 23.5. Your IQR should always be less than your range, because the IQR is just looking from like this point to this point and seeing how much are these spread out, whereas your range is looking at the whole big thing. And so if you get a value for your IQR where it's like, if it's a negative, then something's wrong. And if it's bigger than your range, then something is also wrong. All right, so another measure of variation is called standard deviation. And what standard deviation does is tell us how far a value is from the mean, or in other words, how much each value varies or deviates from the mean. And we're going to use this Greek letter sigma. So remember we talked about capital sigma last week. Now we're talking about lowercase sigma, and we use this to represent standard deviation. And so to find standard deviation, it's going to be a little tricky, but I think that we can handle it. There's some steps that we have to do, and we're going to set up a table to do this. But our first step is to find the mean. We're going to find the mean of all the data, and we call this X bar. We pronounce that X bar. Then we find the difference, or in other words, subtract each value. We're going to take each value and subtract the mean. So some will be positive and some will be negative, and that's okay. Then we're going to square each of those values, and then we're going to find the mean of the square. So this is the technical formula for it, and don't be freaked out when you see that. I think that once we actually do this, you're going to be like, oh, this actually isn't that bad, hopefully. And then take the square root, and that's how you find the standard deviation. So let's try this together. Find the mean and standard deviation for these values. So what we're going to do is start by listing out what are our values. We've got 50, 60, 70, 80, 80, 90, 100, and 110. So then this, it's not really showing up well. It should say X bar. I'm finding X, let me fix that. Here we go. X bar. Don't know why it's not showing up. Sorry about that. All right, let's switch it up. So the average of all of these is 80, because if I add those up, it equals 640, but then I have to divide by 8, because there are 8 values. So my mean, or my X bar, is going to be, I'll pick a different color. That doesn't show up well. I'll pick that one. Is going to be 80, and I'm going to use that all the way down. Average for all of those is 80. So now I'm going to subtract this minus this. And so on this one, you are going to get some negative numbers. So I've got negative 30, negative 20, negative 10, and that's okay. Because look what happens down here. I get positive 10, positive 20, positive 30. So I'm going to get a mix of negative and positive numbers. And it is also okay to get 0 when you subtract them. It might happen. Now, to find, or the next step is to square each of these numbers. So when I do negative 30 squared, I get 900. This is going to give me 400, 100, 0, 0, 100, 400, and 900. So we took care of the first part already, and we're almost done with the second part, but we are going to, what was this? Oh yeah, 80. But now for the standard deviation, what we're going to do is we are going to take the sum of all of these and we're going to divide it by how many terms there are. 1, 2, 3, 4, 5, 6, 7, 8. So when I add up all of these, I get, that would give me 1800 plus 800 and 200. So that would be 2000 and 2800. And then I'm going to divide by 8. And when I do 2800 divided by 8, I get 350. So our final step, is to say, okay, to get the standard deviation, sigma equals the square root of this number. I have to take the square root of it. And when I take the square root of 350, I get 18.71. And we'll round to 2 decimal places. That's a good place. And that's it. So yes, it is a lot of work, but if you organize your work in a table, I think that you'll be okay. So let's try one more. You can pause this if you want. Just keep going. I recommend pausing this and trying it on your own. but I will put all of the work on here. All right, so I went ahead and filled this in. I ran out of room, so sorry for the messiness. My mean, I added all of these together and I got 80, and then I divided that by 10 and I got 8 for my mean, or my x bar. When I subtracted this column minus this column, I got -6, -5, -4, -2, -1, and all of those numbers positive. This won't always happen, it's just the values that I gave you this time. And then when I square each of those values, I get things like 36, 25, 16, 4, 1, 1, 4, 16, 25, 36. And so then I said, okay, now I got to find standard deviation. My standard deviation is adding up all of those. And when I add all of them, I get 164. But then I still have to divide by how many terms there are. And that gives me 20.5. And then final step is to take the square root. So I'm going to say that standard deviation, or sigma, equals 4.53. So that's how we're going to find the standard deviation. And then if they ask for the mean, you could say, oh, the mean is 8. All right, so now we're going to plot the number on a number line and show where the mean is, and then plot the standard deviation. This is so that we can kind of see what the standard deviation means. Remember, we had a standard deviation of 8. Okay, so now our mean was 8 and our standard deviation is 4.53. So if I count by, we'll say I count by 4s. So this would be 4, 0. This would be 12, 16, and 20. All right, so here's where my 8 is. I'm going to start it up here. And then I've got this number line with and I'm going to put my standard deviation of 4.53, so it's just a little bit past 12. And it's going to go like this. And I am making those different levels on purpose. And then I'm going to go just a little bit more, because what happens with standard deviation is when we look at the data, it's going to make a bell curve. Okay, so I know that this might be kind of weird because of the height, but thinking about, here is my mean, my center, and I realize again that I did not draw these well. These are not perfectly straight or spaced out, but you guys have line paper and it will look better. So the idea of standard deviation is that the majority of our data points should fall within one standard deviation. So this one is one standard deviation away, and this is also one standard deviation away. So anything, so 4 fits into that, and 12. And if I look at this, 1, 2, 3, 4, 5, 6 of my 6 of my 10 points fall in one standard deviation away from the mean. They're all very close. And then 2 standard deviations away, I actually account for all of my values. Everything is within 2 standard deviations. So maximum, we're going to see 3 standard deviations away. You very rarely have something that's more than 3 standard deviations. And we can talk more about this tomorrow. But I wanted you to kind of see what it means. It means how far away is it, and it's explaining how far away the data points are from that measure of central tendency. So then last thing is a z-score, and a z-score is the number of standard deviations that a value is from the mean. So you're going to take the value minus the mean and divide by the standard deviation. So if a data set has a mean of 85 and a standard deviation of 6, find the value that has a z-score of 2.5. So they're giving us this, but we don't know the value. We know the mean and the standard deviation. So I know that my z-score is 2.5. I do not yet know the value, but I do know the mean is 85, and I know that the standard deviation is 6. So then it's some two-step algebra. I'm going to multiply by 6, and I get 15. I'm just going to call it v minus 85, add 85. So in this case, my value that I would be looking for is 100. So here's your homework for today. Take a look at that and let me know if you have any questions. I will also answer more questions tomorrow, but try your best, use your textbook, use your notes, and like I said, let me know if you have any questions.